Today we're going to talk about Workbook 3A, Exercise 13. We'll use the textbook page 36 and 37, and this is one of my favorite things because it's the word problems, and it's always interesting to think about word problems in several different ways. On page 36 you see a picture of Jamie and Lindsay, and it tells us that Jamie picked 17 flowers, Lindsay picked 12, they gave away 20 flowers, and the question is how many flowers were left? Well, they call this a two-step word problem because first we need to find how many altogether they had, and then we can find how many they had left after they gave 20 away. So to find out how many they had altogether, you know that that's going to be adding them together. So 17 and 12 gives us 2 10s and 9 1s. There are 29 flowers. Then picked that, so they picked 29. Then the next question is, how many were left? Well, they had the 29 flowers and they gave 20 of them away, so that tells us there were 9 flowers left. Now, did you notice anything as we did that could have made this a little bit easier of a problem? What if we said that Jamie picked 17 and Lindsay picked 12, but if they gave away 20, there are 9 left. Did we have to add to find 29 first? We actually didn't. We could look at the numbers and realize that if we got rid of the 20, that there are 9 flowers left. I like that. I like thinking about the problem and understanding what to do and maybe doing it in sometimes a little bit of a unique way. Let's look at page 37. It tells us that 125 children took part in a competition. It was a math competition. 54 of them were girls. And then the question is, how many more boys than girls were there? The book explains that if we first find the total number of boys first, we know that, I can't help myself. I'm going to draw a picture. There are 125 children. I know that there are 54 that are girls, and then we know the rest of them are boys. And we want to know not just how many boys there are, but how many more boys there are. So by thinking about this, you see that girls is a part and 125 children is the whole. We could subtract that to find out how many boys there are. If I were subtracting this, I would think 12 10s minus 5 10s is 7 10s, and 5 1s minus 4 1s is 1 1. So there are 71 boys. Then the next question is, how many more boys than girls is that? So if I have 71 boys and I have 54 girls, what I want to know is how much more. So this part of the picture is 54. The part I don't know is the second part, and so 71 subtract 54 will give me that answer. I know that 54 plus 6 is 60, plus 11 is 71. That tells me there are 17 more boys than girls. And that's all well and good. That's a good way to work the problem. Can you think of another way to work the problem? What if we said this? Here are the girls. There are 54 of them. Here are the boys. There are 54 of them, and then some more. Altogether, I have 125. I can tell by looking at my picture that these two together are going to be 108. That's some pretty easy mental math. And so I could simply say 125 minus 108, and I would find that there's 17 in this portion. Now that's still 2 steps, notice, but it's kind of a nicer 2 steps because I can add those two. The 108 is a very easy thing to combine. It's pretty easy to double a number. So that's kind of a nice way to work that problem. Notice both of them end with the answer 17 more boys, and so it doesn't matter which way you do it. You don't have to do it one way or the other, but again, what we're trying to do is take that toolbox of ours and put plenty of tools in it so when we come up with a math problem, we can think of a way to solve it, even if it's a little different than ones we've solved before. On page 37, there's a second problem. It says that Ali collected 137 stamps. He collected 27 less stamps than his sister. How many stamps did they collect altogether? This is a great time to make a picture. Ali has 137 stamps. Now think for a moment. If he collected 27 less than his sister, what does his sister's bar look like? Is it longer or shorter than his? Well, if he collected less, she collected more, and so she has the same 137 he has, but then 27 in addition to that. And so really we have 2 options. What we have here is 137 and 137 and 27, and we're going to add those however we want to add them. We could certainly just go straight across and think about hundreds, tens, and ones. Sometimes it's easier to add 2 numbers together at once. 137 and 137 is 274. Add 27 is going to be 301. I just used all the mental math skills we've done in the past to find that there are 301 stamps altogether. The thing that is interesting about this that I just did is that I never actually found out how many stamps the sister had. I just knew that if I want to find this answer, I have 137 twice and then 27 more than that. Now, it doesn't hurt, and the book even suggests that you find out how much the sister collected first. So we could certainly say 137, add 27, that'll be 164. That's how many stamps the sister had. And then you could add 137 and 164. Not surprisingly, you'll still have 301 stamps. And that one is like starting with the 137 and the 27 and combining those and then adding the 137 beside. But we kind of make it into a one-step problem if we just add all 3 numbers together because we have 2 groups of 137. That's how the sister matches Ali's stamps. And then the sister has 27 stamps in addition to that. And so we could do it either way. It's always good to think about word problems from several different directions. All right, so now you can do exercise 13.